Hi, I can see that there are a few people waiting. So I'll just ask if you can hear me. And if you can, like, please write a message in the chat so I can just see that everything works. Perfect. Thank you so much. Thank you. Hi, everyone. I'll just give people 1 more minute to join, and then we'll get started. Can you hear me? Okay. I think we are ready to get started. Let me just share my screen here, get this here away. And yeah, so I have to get used to these technicalities of running a web stream. So I think we should be good up and running now. So thank you all for joining. I've really been looking forward to share this presentation here with you. What I intend with this presentation here is to show you how you as a structural engineer can use Python in your everyday work. And I have included maybe way too many examples, so we have quite a bit to get through. So let's just get started. So wait 1 second. There we go. So the agenda for today's meeting is first a quick introduction. I want to tell you a little bit about who I am, and I want to show you some practical examples of how you can use Python. And then I want to share a proposed learning roadmap for you. So if you want to learn Python, what are the things that I think you should learn? And then I want to give you some brief information about the course that I've just launched. But this presentation is not about the course. This presentation is about learning Python and what you can do with it. So myself, I come from the Technical University of Denmark. I graduated as a structural engineer quite some years ago now. Then I went to Bjarke Ingels Group, worked there as a structural engineer, and then Ramble in the high-rise department, and now started my own consultancy focusing on computational design. And then I have this course, Python for Structural Engineers, as well. So that's my background. But I think the most important thing here is Python. So I've known Python since I was a student. I've always used it for some things, but it was not until I came across this project here that I really understood how useful it can be on projects, especially when working with spreadsheet data and visualizations of results. Now, these plots you see over to the right, they are not for this building here, but it was the same kind of thing we did for this building. We automated a lot of these behavior plots. So rather than sitting and copy pasting data into Excel and extracting one plot at a time, we would just extract all these plots here at once. And basically for everything in this project, we could find, like, there were different things where we could just use Python to set up some templates. So every week when we had a new iteration, we could quickly generate what we needed to generate again. And about Python, it's the fastest growing programming language right now. And also you can see these Jupyter notebooks, which I'll also show, is also exploding in usage. At DTU, 100% of all students now learn Python. So I see that at more and more universities that the students, they're learning Python now. So it is the new thing, you might say. And the reason for it is quite clear. It's easy to read and write, and it can do everything you want to do. So I love Excel. There's not a single bad word about Excel here. I use it every day. But you can see this code down here. It's not very easy to read. Yeah, you can use named cells, but this up here is doing the same thing, but it's a lot easier to read. The reason I show this is because I often come across engineers that say, learning to code is a bit complicated. And then they come and show me this here. I'm like, wow, you can program this. Then Python is going to be a piece of cake for you. So the key reasons to learn Python are that it's easy to read. It's easy to QA. It has a simple syntax, so it's a lot simpler to work with than, for example, C# or C++, like those very heavy languages. It integrates nicely with Excel, like you can work with these spreadsheets in an amazing way. Then you can break it down into modules, like you can make reusable code that you can use in one project, then you can use it in another, in a different context. And there's lots of external libraries that are very well maintained and have millions of users all over the world, and they're free to use. And then it's easy to use AI as assistant. There's so much Python code available, and you have these AIs are training on all available data. So when you use ChatGPT or Claude or some of these large language models, they are really quite amazing at helping you write and understand your Python code. The last thing I want to say about this is that learning Python is not so much about learning how to use a new tool. It's not that now you learn this new thing, another new thing. It's about unlocking your existing tools. Like, how can you work with the tools you already have, and how can you work with your computer in general? So it's an extension of what you already can do, and not necessarily something new. And now this list is for myself, because now I want to show you some examples. I have my other screen over here full of windows that I'm going to drag and drop over. If you have some questions, please write them down for yourself on a piece of paper and then post them when we get to the Q&A session, because I'm not going to look at the questions here while I present. So rather save them for later. So I just want to show you very briefly the simplest example of Python and these Jupyter notebooks. So I go into my web browser, Google Colab, and I can open a Jupyter notebook there. So it's essentially just like a Word document with code in it. So you have some text here. Say this is the Jupyter notebook. All good. Then you have your code, and you can see that the syntax is nice and easy. A is 200, the load is 500, the total load is A times the load, print it. That's as you would expect in like in other softwares as well. And I was just connecting to calculate here. But what I said about reusable code, this calculating the total load, like it's a very simple operation, but it could be more complicated, require more lines of code. And then you can save it in one of these functions here. So now every time I write calculate total load, it says it's one variable times the other variable. And then you can call that function, and you will calculate the total load. And now, like this, you can also do in any other program. But the cool thing about programming is that you can start doing this on more data. So you want to have one load, another load, and a third load, and you want to loop over these loads here and calculate the data for each of them. You run this code cell, and first it runs the code for this value, then for this value, then for this value. This example is very, very simple, but I just wanted to show you the basic gist of what Python can do for you. There's a question, how long will this webinar be? It will be 1 hour. So I hope to spend the next 30 minutes on presenting, and then we have 20 minutes at the end for Q&A. So this example here is not very useful. So let's show some real useful stuff. Now, I said this about extending what your computer can already do. So I want to start with an example along those lines. So let's just say that you're working on a project, and your project manager asks you to produce a document list. So you have a folder, and actually what you would want to do is you just want to list all the files that are inside this folder. And let's just say, like, you also want to send it in an email. So you can go in here and you can start copy pasting names out of all the files that are inside here. Or because you know a little bit of Python, you can ask ChatGPT for help. So you go in, this was my prompt yesterday evening. I say, write a script that extracts a nested folder structure, opens an email with a file list. It's a terrible prompt, this one, by the way. But then it gives me some code. And because I can read this code, I know that, change this and that. This is not good. Actually, I get a bug when I run this code. Can you please help me fix this? And then in the end, I end up with this Python script here. So I haven't written this code here, but I have guided the creation of it because I know how Python works. I know what I can do with it. And I know the syntax, so I can really use AI to help me write it. So now I say, take this folder here and extract the folder structure and open an email for me with it. So I run it here. And then you can see my email is ready, and it's ready to be sent to the project manager at thecompanyIworkfor.com. What if I wanted to also include a check that sees, hey, has any of these files here actually changed since last week? I could also include that. I could see if any files have been added. It's only your imagination that puts a limit to what you can do with this. Any task that you have to do repeatedly or that is really annoying and boring to do, you can set up an automation like this here. So this is what I mean with everyday engineering work. These simple little tasks that you get across. So let me show you another example. Just need to keep track of my windows over here. The next example is to do with find element models. Many find element models can be defined with text files. So you can export your find element model as a text file, then you can change that text file and you can import it again. So let's say we have this file here. This is from Autodesk Robot. And it's just a dummy file, like super simple. But you can see I have all the X, Y, and Z coordinates here. And you can see this one here is nearly -8, but it's not really. This one here is nearly 0, but it's not really. So there's been some mistakes in this model here. Ultra highlighted, as you can see. But what I would want to do is that I would like to input my grid lines in my code, and then I want to snap these points to those grid lines. So in other words, I would like to say that if any of these values are within, let's say, 0.1 meters of an existing value, then update these values in the text file. So I can just edit this text file and then re-import it to my finite element software. And then I've actually edited the model. Now you may ask, can't you just do like an API call or something? Yes, you can, but this here is so much simpler. I'm not going to get more into APIs, but this here is so simple. You're just editing a text file. Everyone can read it. Everyone can understand it. It's easy to QA, and it works. So let's look at the code. If I can just quickly find it behind here. So this is just taken from an exercise that I made. Again, I'm not going to go through the code, but I define here some grid lines. I say that these are the points it should snap to. So it's within 0.1 meters of one of these values here. It should snap to those values. Same for Y, same with the planes. And I can, there's a little visualization error here. There we go. Then I run these lines of code here. And then it says here that it has saved a new file for me. And if we go back here, we can see how it has updated the file. And now, see this one here. Oh, this one is not updated. Why is that? Well, that was because it was not part of our grid lines. We didn't have -8 in here. We have 0, 3, 8, 10, and 11. And you can see it snaps perfectly to those values. So you can update quite complicated things in your finite element model just by editing a text file based on some simple rules. Let's show another example of this here. I'm just going to close these here and then find this one over here. So this is an example from ETABS. So let's say that you have made an ETABS model. So you've designed a tower, and you have received some information from your geotechnical engineer that you need to update these spring stiffnesses. And in your initial model, you just have the same spring stiffness for all the springs, but now you need to vary all the springs. And you know, your geotechnical engineer, he's going to come with new results next week and the week after. Like, you're iterating to find the right values for your spring stiffnesses. So in here, you can see if I go down here, I find point spring properties. I just have this one spring property here. What I want to do is I want to take the data from the geotechnical engineer and add it to this text file. And then I want to apply it to the correct nodes. So I, again, can write a little piece of code. This is a slightly bigger one. This is also like, this is a notebook where I go through the explanation. This is one of the cases from the course. But I essentially take all my pile numbers. They come from the geotechnical engineer. with the pile stiffnesses also from the geotechnical engineer. And then I read through this text file line by line and insert these new pile spring stiffnesses into the file. And you can then see what I get out of it. If I run that file, I get a new file where the only thing I've changed is that I've now added all these point springs. And I go down to my point assigns down here where I assign the springs. You can see that this point 144 has now got spring type 144 assigned to it. So I can now go in immediately and update this here. And then when I get next week the new results, I can update it again. And then I'm going to show you at the end of these presentations another tool where you then can compare the two models with each other. So for some things, it obviously makes more sense to just do the changes manually inside the program, because it's not like, if it's a very simple change, it doesn't make sense to do these kind of checks here. But for a lot of checks, I see engineers sitting for hours on end and updating things manually, where it could be done in a lot faster way and a more robust way. Because here, if your code is correct, you're not going to have any errors. Of course, you need to make sure your code is correct, but there's some different things you can do to ensure that you follow a best practice there. Then the next example, let me see what it was I wanted to show you there. It was, let me just quickly find it for you. Sorry, hang on a moment. Okay, yes. Then one of the very simple things you often want to do is to do some very simple calculations. So let's say we are calculating on a beam, a simple concrete beam, and you want to do a calculation template where you can calculate the capacity of a simple reinforced concrete beam. Then you can create a document like this one here that you can also share with your colleagues. So you have all the explanations in here: depth, width, length of beam, material properties, all these things, and you can write proper explanation to it. And then you may say you can also do that in a lot of other software, which is perfectly true. All of this is nothing special, but it's nice. You can also write formulas properly, so it shows in a mathematically nice way. And then I want to mention that there are also some other libraries you can use to render your calculations. There's a package called HandCalcs that can help you make this even nicer looking. But where this is really, really useful is that you can do these loops, like iterative calculations. So let's just go down. You can see all these calculations we're performing here on this beam, and we're defining different functions. And then we get down to the end where I start to ask some questions. So for example, like if I want to optimize this beam, I want to change, wait a second. If I want to look at, for example, like what if I use 8mm bars? What if I use 10mm bars? What if I use 12mm bars? Like what is the smallest number of bars that I can use? I just realized I was not sharing the right screen. Sorry about that. So here it is. I just quickly want to scroll back a bit to show you these things. So we have the calculation template here. We have these formulas I talked about here that are nicely rendered. You can put in nice figures as well. And then, yeah, we get down to the really cool part, and that is this optimization process. Then you have, say you want to look for 8mm bars, 10mm bars, and so on, and see what is the lowest number of bars that you can use for to satisfy the structural requirements. And then you can just loop over these bar sizes. So we say here, if we use, let's go down to this one here. If we want to use T8 bars, we need 9, and the utilization is 0.92. If we want to use 10 bars, we need 6, and the utilization is this here, and so on. So we can do a loop that performs every single calculation that we have defined And we are not limited to like performing one calculation at a time. You can perform a million calculations. I see that some of you have problems with the video stream. Okay, I hope it's not for all of you. I'm sorry about that. I'm getting asked, what is the name of the notebook you're using for the beam reinforcement topic? This is a template of my own. It's a case, again, one from the course I'm just showing here. One I've written, me and Sam, and yeah, that goes through this. It's a very simple one. So if you want to expand this to also include like deflection checks and so on, you can easily do that. Your screen is not visible. Okay. Just sorry, but why is it? Let me just see here. I'm sorry. Right now, I'm just seeing if I see that you have a frozen stream, and there's a bit of a delay on. It should be sending correctly now. Yes, thank you. It works, and it's visible now. Thank you for letting me know. So, next example. Let's hope for some more luck with the stream, and then I want to show you some of these visualization templates. So another thing that I've had to do for a lot of buildings is vibration analysis. And one of the things you want to check there is like the footfall vibration, whether you are within a comfort limit. And there you often have to create a plot. I just want to show you the plot down in the bottom here. Like this one here. Let's just take this one first. Like a nice logarithmic plot that shows the limit for the type of building that you have, and maybe the baseline acceleration for your building. So this one here is a pretty nice visualization template to have. And then you can, with this matplotlib package, you can add more information to these plots here. So you can actually start creating some really, really nice templates for your visualizations that you can use on every single project you work on. So in this case here, I've made a plot where I have inputted some points from my project. I'm showing the limit, like the overall limit, and then I can add some notes and comments on the plot. And then I can share this script here with my colleagues that are working on another project, and they can use the exact same template. So you have this like nice combination of you have some like fixed element on your plot, and then you can add these custom elements in the template as well. And I use these visualization templates, not templates, but what is called visualization engines a lot. Like Matplotlib is just amazing, and you can get it to look exactly like you want. So this here is just an example of how a notebook could look that you could share with your colleagues to be able to do a nice visualization. So let's look at the next one. So let me just quickly see. Visualization template. And the next one, this one here is my favorite one. Let me get it over on the screen. So let's say that you have now done some of these text file edits. You have created a lot of different models. And I know I'm not sharing anything on the screen right now. And now you have a folder that looks like this here. This could be output files from your project history. So files that look like this here. So analysis files. For every model you have, you output all the analysis data. And you have like here, you have base reactions. You have another sheet in the same file where you have the location of the points. You have another sheet where you have the column forces, and you have another sheet where where you have the modal period, like you have all this information in different sheets in the same file. And then you can have a folder with all these Excel files for your entire model history. But now what I want to do is that I want to compare these models with each other, because often you make some changes in a model and you want to see how did it actually affect my model. So let me show you a template for that. If I can find it here. Okay, let me just quickly open the file. There we go. Now I showed a little bit of stuff here, but let's say that we're doing a sensitivity analysis. So one of the things we want to do is that we want to take our original file, we want to compare it with a file of a different mesh density. So then we could generate 10 different models with different meshes, and we could export all the Excel files and run a script to compare them. So I don't want to show exactly what this here does, but what we're doing here is that we are kind of like merging spreadsheets and sorting them and filtering them exactly like you would do in Excel, except we're doing it automated. If you know VLOOKUP in Excel, a lot of the stuff we're doing is very similar to when you use VLOOKUP. And now we get down to the fun part here. So the first thing I want to do is that I want to merge the spreadsheet where I have my node coordinates with the one where I have the forces. I want to combine them together and create a plot that shows the force distribution in my piles under my building. So this one could maybe need a little bit of text to show like the actual force in the pile. But this is my reference model. This is the one that I started with, and now I want to compare it with all the other different models. So then we go down here, we write some code. I know it's a fair bit of code we're writing for this, but a lot of it you can get help with from your AI assistant. And now we have two different models. See here, I have one where I've updated my spring stiffnesses and I have a fine mesh. And then you can see in here, we certainly get a stronger compression in the piles. And out here, you get less compression in the piles. So this is the absolute difference. This plot you can save automatically to a folder somewhere on your drive and do it for all different load combinations or just the worst load combination, whatever logic you would want to use. You can also do the percentage difference. You just need to define that rule. And then you can clearly see how the different models, like a less stiff model, how does that compare with the full stiffness model? Again, a lot more force in here. We start making the model more stiff, like how does that affect the building? It's a bit of the same pattern, actually. Oh, sorry, that's the stiffness of the piles we're talking about here. But then you can do all of these for all different load combinations, all different models that you're comparing. And then you can also do a plot where you compare the models. So say, well, this model I have here, when I compare that with my base model, I see that my pile reactions, they go up and down by approximately 1%. When I reduce the stiffness by 30%, they go up and down by like up to 10% and down to like minus 3%. And like I've just decided to visualize it like this, but however you would want to visualize it, you can visualize it because Python just allows you to do what you want to do. So this here is, in my opinion, the absolute strongest usage of Python, like this finite element analysis, post-processing, working with spreadsheets in a more automated way. Sometimes you still just want to go in and quickly do something in Excel, but as soon as things get more hairy, more complicated, this is the way you want to go. So this was a very, very quick run through of these examples. And now I want to give you some recommendations on a learning path. So Let me get this up here. So there are 4 things that I recommend that you learn. Like if you're new to Python, the first thing you want to get yourself into is the Python fundamentals. You cannot learn any of the other things unless you got the fundamentals down. And do a Google on Python fundamentals to get an overview of what that involves. But like you need to have the core ready. Then it's Matplotlib. It's this visualization package that is very widely used, and it can be a bit overwhelming, like right when you get into it. But as soon as you get used to it, it's very easy to use. Then it's the OS module, which allows you to work with files on your computer. Like you can go through folders, you can extract information from your folders and files and open text files, and like, you can do all these amazing things on your computer and automate so many tasks. And it's also really useful with all the other things because you can, when you know this module, you can save files, and you can like save files in a proper folder structure. So this one here it's not so great just standing alone, but combined with the other things, it really gives everything some extra power. And then there's Pandas. Pandas is, in my opinion, the most powerful package of them all because it allows you to work with spreadsheets, like spreadsheets, and it's really Excel on heavy steroids. It's amazing, and yeah, learn Pandas. And I'll just mention some other packages here that are cool to look at, like Reportlab for creating PDFs. For all people, for working with units. Oh, let me just get this here away. Handcalcs, structural codes. These are like structural engineering libraries that are really quite neat and very fast to get into as well. Seaborn and Plotly are other visualization libraries that are really nice. Plotly is for interactive plots. And then if you want to work with like more heavy algebra, like matrix calculations, you want to look into NumPy. And now I promised to also talk a little bit about using AI. Let me get to the next slide here. Because there's never been an easier time to learn how to program, and it's never been easier to write code. Since ChatGPT came out, I think I've increased my speed of programming by a factor 10 of something. But there are some good rules, and that is that you should use incremental prompts. Don't just ask it to write a full program for you. Like, ask it to write a few lines at a time. So you start small and then you refine it step by step. If you don't really know what you expect from the AI, when you ask the prompt, you will most likely get a bad result. So you need to know exactly what you expect, and then it basically just writes the syntax for you. And then when you're learning, then ask for explanations. So sometimes what I do is I ask my AI assistant to just say, hey, I need this explained in a like stupid simple way. Why does this work, or why does this not work? What does this bug mean? Can you explain this library? Like, what am I doing wrong? And it's really like having an assistant. So if you ask for these explanations, it can really help you get a better understanding of what you work with. Then focus on data and structure, or structure and data. So in 2024, your primary concern should be to think about like the structure of your whole script. What is it you actually want to do? Like, what is your input at the beginning? What is the output at the end? How can you divide your script into smaller logics? And what is the input and output of each of these small logics? And then when you have taken your big problem and divided it into small problems, then you can get your AI to help you fill in the blanks. But you're going to have a really hard time if you are wanting AI to help you with the whole big thing. Then you end up spending way more time debugging what the AI generated than just writing it yourself. And now I also just quickly want to show something about my course. So all of these things I've mentioned here is what I consider the absolute most important things to learn when you learn Python. So obviously, this course I'm releasing is also following these things. But of course, like, you can also learn these things completely on your own. Like, these packages here are free to use. They exist out in the open, and there are many resources to learn it with. All I've done is to focus it very heavily on the daily work of structural engineers. So it's a 6-week course. We go through the fundamentals in the 2 first weeks. Then we learn how to plot, use Matplotlib. We then work with spreadsheets. We get introduced to how to work with spreadsheets. Then the OS module, so you can work with files on your computer and finite element models through text file automation, as I showed in the beginning. And then in the end, we dive deep into this automation of finite element analysis results, like the post-processing of those results. And like this here is my favorite bit. Oh, here we go. So those are the 5 modules divided over 6 weeks. Then the way the course is structured is that you have the big modules are divided into smaller sub-modules. So we tackle like one little thing at a time. And each sub-module consists of a notebook, like one of these Jupyter notebooks, and then like small videos, 3 to 10 minutes for each topic. Then you have a summary, exercises, quizzes, and plenty of possibility to train. And the last thing I just want to show is that it's $399 plus VAT. So depending on where you live, just like type in your address and see what the VAT is calculated as. And enrollment closes in mid-December. I just want to say that it's self-paced, so you can enroll and just like start whenever you want and do however fast or slow you want. If I ever add anything else to this course, you get access to it. So there's lifetime access to everything. And I don't expect any programming experience, but you should have structural engineering experience. Like if you are an architect, for example, or industrial designer or something, you want to learn Python, I don't think this course would be much fun for you. It's for structural engineers. And then I am very confident that this is what 99% of structural engineers need to have a better engineering life. So there's like 100% satisfaction guarantee. You get your money back if it doesn't live up to expectations. So I'm just going to leave this one here. And that puts us at the approximately 20 minutes left to start asking questions. So feel free to write some questions over in the chat, and I will do my best to reply to them. And if there are some that I don't get to reply on right now because of time constraints, then yeah, I'll send a mail out with more replies. So the first one I get is from Sebastian. Are there any specific computer requirements? Is it compatible with a Mac? Yes, it's compatible with a Mac. And you can, if I just go up here, actually the entire course can run in your browser. Like I've done it so everything can run in this Google Colab, but there are obviously some parts of it that would be nice to work locally with on your computer, but it doesn't matter whether you use Mac or Windows. I think also Linux, but I don't want to do any promises there. Do I have to, let me see here, if there are. So I just get like, Himanshu, what are the terms and conditions for lifetime access? As long as the course exists, like read through the terms and conditions on the page. Does the course get into, let me see, does the course get into working with Git? If no, is this something that you have experience with? The course does not get into Git. To explain Git to everyone here, Git is a way to do like history control of your code. For example, like when I wrote this course here, like me and Sam, the partner in this course, have been using Git to keep track of all our changes, and it's an amazing tool. But I think it's outside the scope of normal everyday use. As soon as you start building larger tools, then look into Git. But it's a recommended further study in the course. And let me see here, Ioannis, thank you for your presentation today. I have 2 questions. The post-processing exercises focused on a specific finite element analysis program? So I have, in the course, I have like exercises with these text file editing where we use a robot. There's a heavy exercise in Autodesk Robot. There's sophistic exercise. There's a GSA exercise. When it comes to the post-processing, I'm using mainly ETABS output, but that's just because it's quite nice and easy to focus on, because that it allows us to focus more on the Python aspects. But it doesn't matter whether you use ETABS, GSA, Robot. I've done the same things for using FemDesign. Done some also what's called a sensitivity analysis with FemDesign. So the course itself is completely independent of the Find Element software that you use. Let me see what else I get asked here. So I see that you use the web browser to run code. Is it not necessarily to install anything? If you Google, just Google Colab, then you get into a web page that is allows you to run Python code within a few seconds. So you don't need to install anything. You can run it online. But obviously, there's some benefit in running code on your own computer where you have access to all your files and you don't need to upload it to your script. Like, you're not uploading it to any unsafe place, but you're uploading it to your script. And it's just nicer to be able to access it locally. But I use Google Colab for simple things, and I work locally for more advanced scripts that work with my own files. Will the course have live lectures? There will not be live lectures, but I'll be active on the course forum. So if you ask questions, I will reply immediately. Immediately, as fast as I can. And I also encourage people to help each other in there. But right now, like, we have, I've already had people enrolled all the way from New Zealand to El Salvador. So to have live lectures just wouldn't make sense due to the time zones. Then let me see. And yes, of course, you get a certificate at completion. Then we have what is Python practice timing required daily to get full benefit of the course? I say whether you take my course or you study Python by your own, it is some weeks of work. I would probably say 3 to 5 hours a week, maybe 6. 3 to 6 hours of study time per week for 6 weeks, or less per week, and then over 12 weeks. But it does take some study time to learn. Then how does the improvement of AI influence the need to learn Python in detail? It's a very, very good question. Because there are, like, when I first learned Python, I would spend 90% of my time fixing little syntax errors, like I'm missing a bracket there or wrote this function a little bit wrong. I don't do that anymore. So you get up on a bit of a higher level now with AI. You still need to understand what you're doing, but you don't really need this like nitty-gritty focus on the exact syntax. I think focus is going to shift more and more from like writing syntax to writing logic. And actually, one of the first videos I mentioned in the course and also here is that learning Python is not about so much learning to write syntax. It's about learning how to think as a computer. You need to be able to define the logic in a way a computer can understand, and that comes slowly through training. And suddenly you realize that you can actually understand much more what you want to do. It becomes less abstract and very much more like, I need to go from A to B, from B to C, from C to D, and so on. But to answer your question, improvement of AI definitely makes it less important to know every single detail about Python. What if someone is already familiar with Matplotlib and the basics of Python? I would say I would definitely still go through the fundamentals fast. Also with Matplotlib, it's actually funny when I wrote this course because I thought I was very familiar with Matplotlib until I dove deep into it. I've just learned it by myself, and then I had to make this course, and I really had to dive deeper into it. I was like, whoa, there was actually quite a few things I didn't know that are super useful. So for the stuff you already know, I would just go fast through it and focus on the things that you don't. The course is like, it's a linear course, so you have to start from the beginning and finish at the end. But you can just say mark complete, mark complete, mark complete. Did you hear about Pinite? So Pinite, I actually have 2 examples as well with Pinite. Pinite is a finite element analysis package for Python where you can do finite element analysis inside Python, and it's actually really, really awesome. So also there, if you want to set up a modeler, say just try to change these parameters and run like 1,000 different analyses of it or optimize things, then you can do it with Pinite. But it's very hands-on. Like you end up spending a lot of effort, like writing your model in code, which is a bit time consuming. But I can imagine, like if you link it with some of the tools you suggest here, like Rhino Grasshopper, you can really get some cool stuff going. So I will show an example in the course with this, but it's not something I'll focus on. Let me see here. Sorry, I'm just reading through the questions, finding like the ones that are most relevant for everyone here. Now, I also get asked about parametric modeling. Like I'm very, very active in the forum of parametric modeling. Like some of you may know Rhino Grasshopper, and I use Python constantly inside Grasshopper as well. But I don't want to focus at all on Rhino Grasshopper because it's a thing for itself. And I don't use Python to generate parametric geometry per se. There I use Grasshopper, but to post-process the data or like do some of these loops inside Grasshopper, I use Python a lot. So it's extremely useful there as well. I don't know if there are any libraries available for parametric modeling. I honestly don't know. But you can use it together with Grasshopper. There's services like Victor, other web platforms that can use Python. So let me see here. I've found that AI is particularly good at helping you code in Python, which makes... yes, that was not a question, that was a statement. I agree. Do I need a license to any FEM software to follow this course? No, you do not need any licenses for anything. There's a place in the course where I recommend that you use Anaconda, which is a super easy way to install Python. There you just have to be aware that if you work in a big company and you install it like on your company account, you may need approval from your IT department to install it, because they also have some license agreements on big companies. But you can also install Python without Anaconda, and then there are no license problems at all. Yeah, sorry, that was myself there. Oh, wait. So he said, the challenge I find are related to collaborative work, as sometimes work that I have developed is later needed to be developed by other colleagues. In your experience, how did you have managed to overcome this in a collaborative environment? This is tricky. It is tricky to collaborate on things, and that's honestly where I love Google Colab, because it's like if you write simple scripts, it's super easy to quickly share them with each other. But what I recommend companies to do is to have like someone responsible for a certain script, and then it's laying in one location, and that's the one source of truth. And if you really want to start building proper big tools and collaborate several colleagues on those, then you have to start using Git, as someone else also mentioned. Which development environment do you use for Python? Do you have any recommendations? I was thinking of using PyCharm. The one that works for you. I personally use Visual Studio Code. I show in the course how to use a Jupyter Notebook without any overheads or anything, like just the simplest way to run Python. So you probably start with Google Colab, then you move to a local Jupyter Notebook, and then you may use to Visual Studio Code or to PyCharm or something like that. What are the different libraries that can be used to link ETABS Grasshopper with respect to Python scripting to generate output results for report preparation? So it's a very interesting question, like a general question, this one, because you're talking about like how can you link software with Python? And there's something called APIs that like nearly every fine element software has an API. What that means is that you can tap directly into the software. So what we have been doing is that we've exported the spreadsheets or imported these text files that we have edited, but we have not actually talked with the software directly. That's what you can do with APIs. I personally have only used APIs when it was some like really proper tools that needed to be distributed in the company, or really needed to update some very specific things. For the quick everyday life of an engineer, you would rarely need to work with APIs, in my opinion. But it could be really helpful if you want to do bigger tools. So for your question, what libraries can be used? You will need to look at your specific software package, see how the API is set up, find some examples to get started, and then you can look into how your finite element software works. Then there's an interesting question here. Try to install Python in previous companies, but had IT reject open source software. How do you deal with this in a corporate environment? This is where I use Google Colab. So there's a lot of companies that have like quite strict policies on like, can you even install Python? And because it's really powerful, but that's why I've decided that the whole course should be able to be run in Google Colab, because you get 90% of the power out of it. And this question about open source, like Matplotlib is open source, NumPy is open source, but like they're maintained by thousands of people. Like it's some of the most amazing development projects. So it's a question for your own IT department, but you can run everything in your web browser without installing anything. Then let me see here. I have someone asking, I've used Jupyter Notebook to write curbs from Labor tests, and you find the, oh yeah, okay, that's pretty cool. So I think like the question starts to slow down a little bit. Feel free, like we have 5 minutes left. So if you have some last questions that you want to ask, then now is the time. I know there's a little bit of delay between me talking and the stream getting to you, so I'm just being patient here. Let me see. Okay, I think there is not so much more coming. So with that being said, I think I want to thank you all for coming. If I have missed your question, or if there's something that you would like to get answered, just please send me a mail. And if it's something that should be shared with everyone, I'll make sure that it also gets out to everyone. So I want to thank everyone for joining here. And yeah, I hope to get a chance to have you enrolled in the course. And if not, I hope that this presentation have given you an idea of what you can do and how you can get started even on your own. Okay, last question here. What do you really suggest for someone aiming to use Python for FEM development? How like get started with Python? Just get started. The only way you learn is by practicing. So everyone, thank you so much. I hope you enjoyed it. And yeah, I hope you get to learn some Python. Thanks a lot.